last time we looked at finding the component form of an airplane or something like the ship or something like that, given a direction angle. And we talked about bearing, finding the component form with a bearing. We're going to look a little bit more at that today. And so we're going to look at just a few examples. So again, just to refresh your memory, a bearing is measured, bearing is 0 is due north and it's measured this way. Direction angle is 0 is over here and it's measured this way around the circle. And the relationship was 450 minus the bearing equals direction angle, or 450 minus the direction angle equals the bearing. Just whichever ones you're given, whichever one you're trying to find. That's the kind of the formula that we used. So let's say we had an airplane, a plane on a bearing of 273 degrees, and he's flying at 383 miles per hour. We want to find his component form. Okay, so first of all, we're given a bearing. We got to find direction angle. So we're going to go, the direction angle is 450 minus 273. You have to take a calculator. And we go 450 minus 273. And I get that it's 177 degrees. So now the component form then of the airplane is going to be its speed, 383, the magnitude of it, times the cosine of its direction angle, 177, 383 sine of 177. And then you just work that out. Just go 383 cosine of 177, and I get negative 382.475, negative 382.475, and we go 383 sine of 177, and I get 20.045. And there's the component form of that. Again, what that is that if you were to draw that out, the x-coordinate part of it would be coming this way, a really big amount, and you go positive a little bit like that. Direction angle is 177 degrees. So it makes sense. Okay? All right, another second type of problem then is we'll complicate a little bit. We have a plane flying on a bearing of 223 degrees at 401 miles per hour. A wind is blowing on a bearing of 87 degrees at 37 miles per hour. So what we want to do is find the component form of both of these vectors. So for the plane, we would go, well, let's see, a bearing of 233, the direction angle then would be 450 minus 233, which, take your calculator, 450 minus 233, and get 217 degrees. So for the airplane, the component form is going to be its speed, 401 miles per hour, times the cosine of 217, and 401 times the sine of 217. You can just take your calculator and you work that out. For the wind, you do the same thing. Its direction angle then is going to be 450 minus 87, which is 450 minus 87, 363 degrees. Now you can use that. It makes no difference. You can subtract the 360 and find out that it's actually 3 degrees. But it makes no difference, so I'm not even going to do extra work. I'm just going to go then its speed, 37, times the cosine of its direction angle, 363, and 37 times the sine of 363. And then you just put these in your calculator and write down what you have. So this one up here, I got rid of this, I have room to write it in there. I'm going to go 401 times the cosine of 217 minus 320.253 and 401 times the sine of 217 comes out to minus 241.328. So there's for the airplane. For the wind, 37 times the cosine of 363, 36.949, and 37 times the sine of 363, which is 1.936. And there's for the wind, there is for the airplane. Next time we'll look at what we do with those to find out where the plane actually goes. Now one more type of problem that can be done with this is using forces. Quite often forces act on a single body. You got the direction something's going and a force acting this way, and so we're going to look at several different forces acting on this, and we want to find the component form of each one of them. And so let's say that we have force 1 is 100 pounds at a direction angle. So force 1 is 100 pounds at a direction angle. Now make note of that. It's direction angle. So we don't have to do any of this bearing stuff. Direction angle of 97 degrees. Force 2 is 87 pounds. No, excuse me. Is 93 pounds at a direction angle of 172 degrees. And force 3 is 108 pounds at a direction angle of 313 degrees. So you can see that I got this vector 97 degrees, so that'd be 90 plus 7 more. So let's go in here, and that's 100 pounds. I have 93 pounds at a direction angle of 172. So this is force 1. 173 degrees, 2 degrees, would be down here kind of like this, and that's going to be 93 pounds. I guess I can't draw it that long since it's less than this one. So 93 pounds, and this is 97 degrees, this is 172 degrees, and then 108 pounds at 313 degrees. Well, 313 degrees is this way, so there's 108 pounds, and it's going to be at 313 degrees. To find the component form of each of those, you just do the same things we've done before. For force 1, the component form is going to be 100 times the cosine of its direction angle, 97 degrees, 100 times the sine of 97 degrees. For force 2, it's going to be 93 times the cosine of 172, 93 times the sine of 172, and force 3 is going to be 108 times the cosine of 313, 108 times the sine of 313. And then you just put those in your calculator and you get your answers. So 100 cosine of 97, and I get negative 12.187, negative 12.187, 100 sine of 97, and I get 99.255, 99.255, and there's the component form of force 1. Do the same for the other ones, 93 cosine of 172, and I get negative 92.095, and 93 sine of 172, and I get 12.943. And finally, for force 3, 108 times the cosine of 313, and I get 73.656. And 108 times the sine of 313, and I get negative 78.986. And there's the component form of the three forces. Okay, that's what your assignment's on. Good luck. Let me know if you have questions.